Experts have started examining the samples of asteroid Bennu, and they've discovered that the space rock might actually be a fragment of an ancient ocean world. At the moment, scientists are still inspecting bagged and tagged chunks of the 4.5 billion-year-old asteroid. They were collected in space and brought to our planet by NASA's Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer mission, also known as OSIRIS-REx. This 7-year-long voyage brought the samples in a return canister that came to a full stop on the 24th of September, 2023. It parachuted into a remote stretch of land in Utah. Scientists at the University of Arizona got roughly 7,000th of an ounce of the asteroid Bennu sample for analysis. There were over 1,000 particles greater than 0.02 inches and 28 particles greater than 0.4 inches. The largest particle was 1.4 inches. It's considered to be an awesome collection, full of relatively large stones. The OSIRIS-REx sample is the biggest carbon-rich asteroid sample that has ever been brought to our planet. It also contains nitrogen, sulfur, and phosphorus. This space rock might help researchers investigate the origins of life on Earth. What makes the asteroid material so unique is the fact that it was captured in space. Most meteorites have to endure a fiery fall through the atmosphere of our planet, and we can only get our hands on their changed bits and pieces. Plus, OSIRIS-REx samples have a phosphate crust never seen in meteorites before. Such high concentrations of phosphate have been previously detected in extraterrestrial ocean worlds. For example, Saturn's moon Enceladus contains phosphates, which is a key building block of life. It makes scientists think that Bennu could be a fragment of an ancient ocean world, too. Even though a lot of work is needed to understand the nature of the carbon compounds found in the asteroid pieces, the whole discovery looks promising. It can offer us insights into how the solar system was formed and how life might have been seeded on Earth. The goal of the OSIRIS-REx mission was to get at least 2 ounces of asteroid material. Experts at NASA were working in new clean rooms constructed especially for this purpose for 10 days in a row, carefully disassembling the sample. Interestingly, when the canister lid was first opened, scientists discovered some bonus asteroid material covering the collector head, canister lid, and its base. There was so much additional material that it slowed down the process of collecting the primary samples. Luckily, NASA's scientists and engineers have been working side by side for years, developing specialized glove boxes and tools that could keep the asteroid material pristine. Within the first 2 weeks, researchers made some quick-look analyses of the initial material. They collected images from a scanning electron microscope, examined infrared measurements, and conducted a chemical elements analysis. X-ray computed tomography was used to produce a 3D computer model of one of the particles. Exactly these early glimpses provided the evidence that the sample contained pretty much carbon and water. Scientists believe that the carbon-rich material, with quite a lot of water-bearing clay minerals, is just the tip of the cosmic iceberg. They hope that each new revelation from Bennu will bring us closer to unraveling the mysteries of our space heritage. For the next few years, the mission's science team will keep characterizing the samples and conducting analyses needed to make more discoveries. NASA is going to preserve at least 70% of the sample. As part of the OSIRIS-REx program, more than 200 scientists all over the world will explore the properties of the regolith. Almost everything scientists at NASA do is dedicated to figuring out who we are and where we come from. And such missions can also improve our understanding of space wanderers that might threaten Earth.
In 2007, astronomers spotted a massive 54-ton asteroid roaming space relatively close to our planet. But later they lost track of it. That's why the space rock was declared a lost asteroid. Almost 2 decades have passed since then. And in November 2023, a report claimed that the lost asteroid, aka 2007 FT3, might hit Earth in 2024. Such news sounds ominous. But how true is it? Well, NASA disagrees. The U.S. Space Agency has refuted the worrying claims. This statement was issued in response to the announcement that there was a 1 in 11.5 million chance of the asteroid striking our planet on the 5th of October, 2024. The space agency states that at any time in the next century, there are no known asteroids that could pose an impact threat to Earth. NASA and other space agencies are watching the skies nonstop, determined to find, track, and categorize asteroids and NEOs near Earth objects. Hundreds of millions of rocks orbit the sun within the asteroid belt between Mars and Jupiter. But only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects. Inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they might turn into a real threat to the world should a direct collision occur. Luckily, the larger an asteroid is, the easier it is for our planetary defense experts to find it. The orbits of the largest space rocks around the sun are normally well known and determined for years and even decades. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object reaching 1,610 feet across. It might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. But even though Bennu's chances of colliding with Earth are quite low at the moment, the space rock has still been categorized as a potentially hazardous asteroid. All because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Asteroid 99942, 942 Apophis, also known under the dramatic name of the God of Chaos, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years.
What would you do if one day you went outside and saw something bright and greenish in the sky? People around you would be filming the bizarre spot of light nearing the planet. This space wanderer, similar to a falling star, would be getting closer and closer. A comet. What would you feel? Panic? Luckily, there's no need. Even though you can see this comet from Earth with the unaided eyes, it's not going to destroy Earth. Comet Pons-Brooks is no danger to us. It's a short-orbit space body orbiting the Sun every 71.2 years. In fact, any comet with a period less than 200 years is considered short period. Astronomers have known about Pons-Brooks since 1812, but in the past, the observations of the comet weren't precise enough to predict when or where it would come back. That's why the comet was kind of rediscovered in 1883 by William Brooks, hence the name. But wait, look at the comet more attentively. Are those horns? Yep, and this weird feature caused people to give this space body a nickname, the Devil Comet. In late July 2023, the comet experienced an outburst, blowing off a bunch of dust and gas and brightening around 100 times. Such outbursts are unpredictable, random, and not really common for comets. The outburst made the coma, the freely escaping atmosphere around the nucleus of a comet, forming when it comes close to the Sun, distort into a horned or horseshoe shape. This shape has a dark center and bright wings. After the outburst, the comet settled down again. Its brightness has been steady for some time until it outburst once more. And guess what? The horns appeared again. Astronomers aren't completely sure what might cause the horns, but they believe it could be the fact that the comet spews gas and dust unevenly. One area of the surface that isn't blowing off steam remains dark, and the areas to either side of it are bright. It might also be a shadow effect. The denser material at the center of the comet seems to block some of the bright material behind it from our point of view. Astronomers claim that the comet itself is likely to be bigger than Everest. Of course, it's hard to figure out the size of a comet without observing it directly via a spacecraft or radar. But base it on its brightness, its nucleus, the chunk of rock and ice making up the body of the comet, might be a bit more than 10 miles across. It's even bigger than Everest. The seas might actually be overestimated since the method used for this analysis doesn't allow us to tell exactly where the nucleus stops and the coma begins. Now, let's figure out whether this horned beast presents any actual danger to Earth. Well, it is heading our way. Kinda. You see, Ponce Brooks can indeed come pretty close to Earth, and still, the comet isn't as close to us as Venus. When the Devil Comet comes into and then flies out of the solar system, and one might think it must cross the orbit of Earth to get there, but it doesn't. The thing is, space is three-dimensional, and while the planets of the solar system orbit the Sun in a flat plane, comets don't usually follow the same rules. Ponce Brooks has a very inclined orbit, bringing it down from above the plane in which the planets orbit when it rounds the Sun, which means that the comet in question passes between the orbits of Earth on the outside and Venus on the inside before heading out of the inner solar system. In other words, there's no threat of a collision whatsoever. By the way, Ponce Brooks could be seen during the total solar eclipse on the 8th of April 2024. The Space Wanderer was approaching its closest point to the Sun in its orbit and was bright enough to see with binoculars.
2 decades ago, in 1999, we stumbled upon a unique diamond-like celestial object. This asteroid was named Ryugu, derived from a Japanese word meaning Dragon Palace. The name originates from a Japanese legend about an enchanting underwater palace. In this tale, a fisherman ventures to this palace, riding a turtle, and comes back bearing a peculiar box. Echoing this story, the Japanese spacecraft journeyed to Ryugu around 2 years ago, retrieving enigmatic samples from its surface. The asteroid's terrain, dotted with craters and stones, suggests a tumultuous history. The spacecraft retrieved a specimen from Ryugu's surface, and upon its return to Earth, scientists made a fascinating discovery. The asteroid predates our own solar system. The mission aimed to procure this sample to shed more light on the beginnings of our solar system. However, this isn't the inaugural discovery of such ancient particles. Similar grains have been identified in various meteorites before. They often contain a significant amount of carbon, akin to Ryugu. Yet, Ryugu possesses a distinct composition not found on Earth: silicon carbide, a pure blend of silicon and carbon. The composition of Ryugu is so distinct that it suggests the asteroid originated in the outer realms of the solar system. It is one of the trio of asteroids that, while revolving around the Sun, maintain a proximity to Earth. Essentially, these asteroids are clusters of fragmented rocks bound together by their mutual gravitational pull. They are believed to have come into existence after larger celestial bodies collided, breaking into smaller fragments. The individual stones of Ryugu could date back as far as 4.6 billion years, hinting at their origin from a parent entity. However, some theories propose that the asteroid's surface might be a relatively younger 158 million years old. How can we determine the age of our solar system? Billions of years ago, in a distant and nearly lost section of the Milky Way, existed a molecular cloud. Like many others throughout the cosmos, it began to disintegrate and collapse, a natural process leading to the birth of stars. From this particular cloud, several stars emerged. One of them, slightly secluded from the rest, began gathering surrounding materials, evolving into what we term a protoplanetary disk. This rotating disk of gas and dust encircled what would eventually become the nucleus of a solar system. Over time, this disk gave rise to various celestial entities, including asteroids and planets. Eventually, our Sun, 8 planets, and various other celestial objects that we recognize today as our solar system emerged from it. This system is estimated to be around 4.6 billion years old, over spans ranging from hundreds of thousands to millions of years post the star's emergence. Planets begin to take shape. While many celestial bodies from that era may have vanished, the configuration of our solar system has largely remained consistent since its inception. By analyzing the constituents of various objects, researchers have uncovered fascinating insights as they examine minerals, stones, and solid entities. The elemental makeup of these objects provides clues about their age. Scientists have investigated meteorites that have fallen to Earth. Believing these meteorites and Earth belong to a shared system, they estimated their age to be around 4.54 billion years. Lunar rocks, which haven't undergone the same transformations as terrestrial ones, are younger by several million years. The Sun, our solar system's core star, might be slightly older, perhaps by tens of millions of years compared to the oldest rocks. The general sequence is stars forming first, followed by planets and other solid entities. So it's plausible that the Sun is nearing 4.6 billion years in age. Among the known moons in our solar system and beyond, Jupiter's moon Callisto stands out as the oldest. It's a rugged, icy body marked with numerous craters, indicating its history of collisions over its believed 4 billion years of existence. These craters suggest it's been a target for space debris for quite some time. Moons like Callisto around Jupiter likely originated from the remnants left after Jupiter's formation. While these durations sound vast, consider that the universe itself is approximately 13.7 billion years old, hinting at even older entities existing out there. Recently, astronomers identified one such ancient and distant entity, the galaxy, located 12.8 billion light-years away. This galaxy began its formation just 1 billion years after the universe's inception, shortly after the Big Bang set everything into motion. Wait, please subscribe.
So, theoretically, humans can survive an asteroid that has the potential to destroy entire planets. It won't be a walk in the park, though. Let's go back in time to 66 million years ago, in the late Cretaceous period. The Earth, before humans, where dinosaurs are thriving. The plants and animals are rich and diverse. You'd see a T-Rex chasing a Triceratops, or the massive Alamosaurus, one of the biggest animals to ever roam the planet, towering over the landscape. In Texas, they remember the Alamosaurus. And watch out for the Ankylosaurus, a living tank swinging its tail like a wrecking ball at any threat. As you're about to enjoy a quiet evening under the stars, a bright new light appears in the sky of the northern hemisphere. Now, a new star in the sky doesn't really stand out at first. It's just twinkling like the rest. But give it a few hours and you'll notice it's getting brighter. Check again the next night and boom, it's the brightest thing in the sky, outshining planets and even the moon. Then finally, it horrifyingly outshines the sun. The star was the Chicxulub asteroid, which left a gigantic crater now called Chicxulub Crater in Mexico's Yucatan Peninsula. The asteroid enters the Earth's atmosphere at a blistering 12.5 miles per second. It blasts through 60 miles of the atmosphere in about 3 seconds. It falls so fast that even the air can't get out of its way. The air gets squashed and heats up to thousands of degrees in a blink. Before the asteroid even touches the ground, this super-hot air has already vaporized much of the sea where it's about to strike, near the Yucatan Peninsula. Then, in a flash, the asteroid smashes into the Earth, screaming over Central America with a loud boom that echoes everywhere. It doesn't just smash the ground, it makes the soil and rock flow like liquid. The asteroid digs a hole so wide and deep that it nearly touches Earth's inner layers and throws up dirt more than 20 miles high. At that exact moment of impact, the asteroid also turns its massive speed and weight into heat in a split second. It puts so much energy into the Earth that it makes molecules move faster than the surface of the Sun. This massive energy created a giant ball of plasma, superhot charged gas that includes bits of vaporized rock. This all shot out at incredible speeds. The shockwave from the impact and the heat turned the Earth around the crash site into gas instantly. This set off earthquakes all around the world. And it's not just the rocks flying around that you need to worry about. As they plummet through the sky, they rub against the air, heating up so much that they set fires all around the world. The heat they give off could be compared to an oven cranked up to its highest setting. This fiery shower causes most of the world's trees to burn down. The entire world is now on fire. Soon it changes everything. In a blink, dinosaurs were wiped out, making way for mammals to rise. And not only dinosaurs, 75% of species and big creatures disappeared, leaving behind only some small birds and critters. So, how could you, a human, survive something like that? Now, some animals made it back then. To survive, we need to learn from their resilience. The only birds that survive even in the toughest conditions are the ones nesting safely on the ground. Among the few larger animals that manage to dodge extinction, all have ways to deal with the heat. Some, like certain small mammals, snakes, and lizards, can dig themselves into cooler underground burrows. Others, like crocodiles and turtles, just hide in the water. So, if you're exactly on the other side of the planet when the strike happens, and you act super fast, you might just make it. Right now, the impact is about 10,000 miles away, but don't underestimate its power. As soon as you hear the loud boom, head underground as quickly as you can. And be careful, because you'll feel the Earth shake about 30 minutes later. Hide in a deep cave, preferably with a narrow entrance. It would protect you from the falling debris, and the temperatures underground would be stable. Also, some caves have natural water sources, rivers or streams. You might also prepare for the not-so-great diet of insects, fungi, or poor small animals that also seek refuge in the cave system. But it's better than nothing. You also need to be extremely far away from any large bodies of water. Being near the ocean might seem like a safe bet during a massive asteroid impact because the sea can buffer extreme temperature changes. But the earthquakes trigger terrifying tsunamis, even in lakes or fjords. The asteroid's crash sets off not just one tsunami, but many, and they're as tall as skyscrapers. Within an hour, colossal waves between 600 and 1,000 feet high hit the Gulf Coast, slamming into places like Mexico and the southern United States, and flooding miles inland. These waves are so powerful, they even push rivers backward. These tsunamis continue around coastlines, reaching the east coast of the United States, and 6 hours later, they hit Europe, Africa, and the Mediterranean. By 15 hours after the impact, there isn't a coastline on Earth that hasn't felt the wrath of these waves. Well, let's say you survived the initial impact somewhere deep underground, but your troubles have only begun. The Chicxulub asteroid strikes a region loaded with sulfur. This sends 100 billion tons of sulfur and an enormous amount of water into the sky. The water vapor forms massive storm clouds. They start to rain acid. In colder places, huge snowstorms bury the land under feet of snow each day. The impact also vaporizes massive amounts of oil, throwing up 150 football stadiums worth of it into the air. This oil turns into a thick black soot in the stratosphere. It coats the Earth like black paint. And even when the acid rain calms down, this carbon stays up above the clouds and doesn't wash away. This sooty layer blocks out 90% of sunlight, plunging the Earth into a cold darkness that lasts for at least 3 years. The world cools down by about 50 degrees on average. Now, when you finally leave your deep cave, you must look for places where you won't freeze. The only spots spared from the frost are tropical islands like Madagascar, India, which was an island back then, and Indonesia. These places have surviving plants and animals, and they even continue to get fresh water, unlike most of the world. Everything else in the world looks like a huge nuclear wasteland. These tropical islands are safe spots during an asteroid apocalypse, but don't think of them as paradise. These places still only get about 10% of their usual sunlight and barely enough rain to avoid turning into deserts. In this chilly, gloomy setting, most food chains fall apart. If you want to survive, you'll need to bring lots of extra food with you, for the next 6 years at least. Now, some things are lucky enough to survive. Fossils tell us that freshwater ecosystems did well, so staying close to a river or estuary might be your best shot at finding food. You could come across turtles, crocodiles, and some fish. Animals like clams, snails, and small crustaceans that live in the sediment also manage to hang on. And while a bit warmer than everything else, these places are no walk in the park. You'd need to pack warm clothes to have any chance of survival. Now, if we add all this together, the best spot for surviving the Chicxulub asteroid would be Indonesia. It's a mountainous, tropical country that consists of several islands. There, you'll find bearable temperatures, a bit of rainwater, and a deep cave for shelter. This could protect you from the falling tektites, the intense heat, and even help you find something to eat in the rivers and lakes. But if you stumble upon any shrew-like creatures while scavenging for food, time traveler, please let them be. It's not clear how many survived the Chicxulub impact, and eating one could have unforeseen effects on the future of humanity. Like, don't eat your great-great-great-great-great-great-grandfather, right?
Seen a good horror movie lately? If you're a fan of those, then you can appreciate a good plot. But what if I told you that Mother Nature is the best scriptwriter ever? Ancient disasters were scarier than any horror movie today. From tsunamis to volcanic eruptions, you'll be shocked by the scale of these events. One natural disaster you definitely don't want to experience is a tsunami. Those gigantic walls of water sweep across the coast and take out everything in their way. And it's nothing new for our planet. Scientists were able to piece together a timeline based on evidence that major tsunamis left. In northern Chile, a large boulder sits high above the Pacific Ocean. Behind it, a desert as far as the eye can see. This 44-ton stone obviously doesn't belong here. It's the result of an ancient tsunami. Waves as high as a 6-story building carried boulders like pebbles. Researchers estimate this happened in 1420. But how can they possibly know this? In the 15th century, there were no written records in the region. Time for some detective work. Archaeologists discovered that around the same time, there was a tsunami in Japan, on the other side of the Pacific Ocean. The ground shook off the coast of Chile. That's how the tsunami was created. Then the wave traveled nearly 2/5 of the Earth's circumference. That's one tireless tsunami. But this wasn't a one-time event. Evidence suggests that a similar event happened 3,800 years ago. Ancient people abandoned their coastal villages around this time. They were moving inland. How did they know it was time to go? There's evidence of erosion due to strong currents, telltale signs of an ancient tsunami. As you know from school textbooks, oxygen is 21% of the air we breathe. But it wasn't always a part of Earth's atmosphere. Oxygen was missing during the first half of our planet's lifespan. Carbon dioxide and methane were the name of the game back then. CO2 is what makes our drinks fizz. But isn't the other gas dangerous? Yes, because you can't smell methane. And that's the reason there was no life on Earth billions of years ago. So how did we get from methane to oxygen? In come the cyanobacteria. This group of microbes started to evolve some 2.7 billion years ago. These tiny microbes mastered photosynthesis, converting sunlight into energy. And the byproduct of this process was, you've guessed it, oxygen. Soon it started escaping from water into the atmosphere. There, it reacted with methane, and over time, O2 replaced it completely. Scientists named this process the Great Oxidation Event. But how could it be bad? After all, we're alive thanks to it. All that oxygen acted as a poison for anaerobic organisms. And no, these are not life forms that didn't do aerobics or Pilates. The term simply means that these microorganisms didn't need oxygen to grow. Too much oxygen, and they would be goners. And that's precisely what happened. Scientists spoke of an oxygen overshoot that changed Earth's atmosphere for good. The disappearance of most anaerobic organisms was an early example of an extinction event. They didn't like the atmosphere at the time and decided to step down. But look on the bright side. They made room for oxygen-loving humans to enter the picture. Let's go to Turkey. No, not the seaside resorts that tourists visit in the summer, but the region of Anatolia in the southeast of the country. Göbekli Tepe is the world's oldest known temple site. It dates back to the Neolithic period. Scientists found a stone pillar here that tells a tale of an ancient disaster. They presume that the pillar is commemorative. Today, humans still build similar structures to mark an important event or a person. Just one example is the Washington Memorial. It was built in honor of the first American president, George Washington. But the pillar in Turkey doesn't commemorate a happy event. Scientists believe it shows a devastating occurrence, a comet crashing into the Earth. The event must have been destructive. There are also other signs on the monument. These symbols align with the setup of the night sky stars for the year 10,950 BCE. The date astounded the researchers. It matched their earlier research of an ice core sample in Greenland. This showed that a comet fragment hit our planet around the same time. The archaeological site could have easily been an ancient observatory. And whoever worked at it observed a cataclysmic event. The impact must have been so powerful that it changed the Earth's rotational axis. That's the imaginary pole going through our planet from top to bottom. That ancient comet must have packed a punch to knock the blue planet off balance. Have you heard of the city of Tal El Hammam in the valley of the Jordan River? The reason why your answer is probably no is that the city doesn't exist today. It completely disappeared around the year 1650 BCE. It was one of the three major cities in this part of the Middle East. Together, these three cities had a population bigger than Palm Springs today. At the time, Tal El Hammam was a metropolis. It even had high-rises, 5-story buildings constructed using mud bricks. But archaeologists found strange markings on them. The bricks melted as they were exposed to high temperatures. Yes, sound the fire alarm. Some sort of disaster had caused a major fire. Archaeological finds pointed to a suspect for such damage, a rock from space. So, where was the crater? This comet, or an asteroid, never made it to the ground. It was traveling at high speed, so it disintegrated before hitting the ground. Such an event is called an airburst. The largest witnessed meteor airburst happened over Tunguska in the north of Asia in 1908. Scientists estimated that the airburst in Tal El Hammam happened 2.5 miles above the city. This event released a lot of energy. Air temperature quickly rose to 3,600 degrees Fahrenheit. That's hot enough to set clothes and wood on fire in an instant. Mud bricks and tools made from metal start to melt when exposed to such heat. This would explain the evidence scientists unearthed. But there was one more find: salt. The event was so powerful that it distributed salt over the region around the Dead Sea. Any farmer will tell you that salty soil and crops don't go well together. People started moving away from the area because they couldn't grow food. Imagine an island with whitewashed villages surrounded by a sapphire blue sea. Such a place exists in reality. It's the island of Santorini. But the history of this place hides a tale of destruction. The island is of volcanic origin. This means that a violent eruption created it some 3,000 years ago. Now there are two islands. The bigger one is shaped like a horseshoe. When you look at them from above, the two islands look like they form a circle. That's because they were once a single island. It had a large mountain and was round in shape. But then it all changed almost overnight. One of the largest volcanic eruptions in human history tore Santorini apart. The earth trembled, tsunamis formed, and clouds of ash filled the sky. A daunting image. People felt the eruption hundreds of miles away. When it was all over, seawater rushed into the caldera of the former volcano. That's why the water in the lagoon has such a beautiful color. Scientists know so much about Santorini's past because of an unlikely assistant, a tree. The juniper tree, to be exact. People use its aromatic wood for everything from furniture to making pencils. On the Greek island, its rings revealed the tale of the ancient eruption. As a tree grows, it doesn't only go up, it expands sideways as well. Each new layer of bark adds a ring to the trunk. It takes a year for one ring to form. And on Santorini, one ring was unnaturally pale. The scientists did the math and voila, they dated the eruption to 1560 BCE.
Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth, in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system.
We're flying past the planets of our solar system. We pass by Mars, Jupiter, Saturn, Uranus, and Neptune. Then we move through dark space beyond the edge of our world. We've reached our destination. It's the Oort cloud. It's a hypothetical region around the solar system that holds tons of asteroids and blocks of ice. It's likely to be where the largest comet in human history was born. And now, it's heading toward the sun. Bernard and Ellie Bernstein was discovered totally by accident during the Dark Energy Survey. Our telescopes were pointed at distant space. Their main goal was to learn more about how the universe was expanding. Astronomers also wanted to make a more detailed map of the observable universe. Scientists analyzed over 80,000 images and found a moving object. It was alarmingly close to our home planet. Its size was an impressive 62 miles. That's about the width of Lake Michigan. It was an already active comet with a long tail. Usually, comets get a tail when they come close to the sun. The heat from the star warms the comet's surface, and light materials, like ice, begin to evaporate. This forms a cloud of steam and dust that stretches far beyond the comet. But Bernard and Ellie Bernstein is too far away from the sun to start heating up. This means that its surface has a different composition. It might be solid carbon monoxide. This increases the luminosity of the comet. That's why it can be observed with telescopes on Earth. We can compare Bernard and Ellie Bernstein to the largest meteorite to ever fall on Earth. About 66 million years ago, our planet was hit by a meteorite about 6 miles wide. At that time, the blast wave from the collision went around Earth several times. Tsunami waves caused by the impact were taller than the largest skyscrapers, and the energy from the explosion set huge areas on fire. Almost all living creatures, including dinosaurs and ancient fish, ceased to exist. The meteorite left a crater 3 times the size of Manhattan. The place where it fell was rich in sulfur. This substance evaporated because of the abnormal heat and gathered into massive clouds. This caused acid rains that were falling on Earth for several more weeks. Our newly discovered comet is 10 times bigger. If it were flying toward Earth, you'd see it with the unaided eye long before the impact. It looked like a moving star in the night sky. A few days before the comet reached our planet, you'd see it even during the day. You'd be able to distinguish its long tail, too. When the comet entered the atmosphere, it produced a booming sound so loud you'd hear it on the other side of Earth. At this point, the comet would begin to heat up because of friction with the air. It'd start burning. Countless pieces of debris would break away from the main body of the meteorite and fall to Earth. As soon as Bernard and Ellie Bernstein touched the surface of the planet, we'd see a flash so bright it'd outshine the sun. In a fraction of a second, a colossal amount of energy would be converted into heat. This would create the most powerful explosion in the history of our planet. It'd literally rip out chunks of ground and throw them into the air. The blast wave would incinerate everything within a few hundred miles. It continued to spread in different directions, breaking and bending trees. At one point, it reached snow-capped mountains and trigger huge avalanches that would cover many villages. The blast wave would go around the planet, shattering glass and buildings on all continents. Tsunami waves would be so high they would cover entire coastal cities. The most powerful earthquake in history would break the ground and create deep cracks. After the impact, billions of tons of dust and ash would rise into the air. A giant black cloud would completely block the sun's rays. Earth would be plunged into darkness. All the debris in the air would start melting. They'd turn into liquid lava and fall back to the surface, causing even more damage. The ash and dust in the air would cover the sun for several more months. During this time, the temperature on Earth would drop by several degrees. Even if they were hiding in deep shelters and bunkers, people, as well as all other living organisms on the planet, would be unlikely to survive this event. Fortunately, Bernard and Ellie Bernstein isn't going to approach Earth. Right now, the comet is about 20 astronomical units away from the sun. That's 20 times the distance from Earth to the sun. It means the comet will soon cross the orbit of Uranus. In 2031, it'll be 11 astronomical units away from our star. That's just outside Saturn's orbit. This is going to be the closest Bernard and Ellie Bernstein will approach the sun. Then it will begin its flight back to the edge of the solar system. But the comet is bound to return again. It'll move away from the sun and slow down until the star's gravity pulls it back. Then the comet will make another circle around our solar system, but that will take about 3 million years. Right now, we have other meteorites to worry about. For example, 3200 Phaethon. It crosses the orbits of Mars, Earth, Venus, and Mercury. Then it goes around the sun and comes back. This cycle takes about 523 days. Then it starts over again. This meteorite is considered potentially hazardous because it crosses Earth's orbit at 7.5 Earth-Moon distances. During one of its last approaches to Earth, this 3.6-mile wide block of rock showered our planet with small meteors. Since the asteroid often passes by the sun, its surface is most likely to look like the dry bottom of a mud swamp. It's covered in scales and cracks. As it flies past Earth, these scales break off and cause meteor showers. But the largest, potentially hazardous asteroid is the 1999 JM8. It's about the size of 77 soccer fields. It passes by Earth at 9 lunar distances. Its closest approach to our planet will happen in August 2137. If such a meteorite were to hit Earth, an entire continent could be wiped out. The rest of the world would experience massive tsunamis, but would survive the event. So naturally, scientists are thinking of ways to protect the planet from such a disaster. The first solution is a controlled Big Bang. One of the laws of physics says that if you apply some force in one direction, it'll cause a reaction in the opposite direction. So if we spot an asteroid that is about to collide with Earth, we'll need to send a rocket toward it. This way, we'll produce a controlled explosion, not inside, but right above its surface. The blast will be directed upward, and the asteroid will shift downward. Even this tiny shift would be enough to change the trajectory of the asteroid, and then it'll fly past Earth. Another way is to send a heavy object, like a spaceship, toward the space body. Every heavy object has its own gravity, so the spacecraft will have to fly close to the asteroid, which will attract the ship to its surface, but the engines of the spacecraft will resist. The ship will start pulling the asteroid in the opposite direction. This will change the trajectory of the asteroid, and our planet will remain intact. We can also ram the asteroid with the spaceship. Bam! Or we could build a space station, like the ISS. It would be equipped with a bunch of huge magnifying lenses. We would send the station closer to the sun and start looking for potentially hazardous asteroids. Then, we'd point all the lenses so that the sun's rays would focus on the giant rock. The heat would begin to vaporize the matter from the asteroid's surface. That's where physics would come into play again. The matter would evaporate upward, and the asteroid would move downward. We could also wrap the asteroid in a reflective film, something like foil. Usually, space bodies absorb most of the sun's rays, but if the asteroid was covered in foil, the rays would bounce off its surface. This would create a weak pushing force. That should be enough to avoid the collision. Of course, we could attach rocket engines to the asteroid. This way, we would be able to not only change its trajectory, but also control it. But that would depend on the size of the asteroid and the number of engines. And then, we could use this massive rock to ram it into other, larger asteroids.
If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it is, it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet. And we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX, and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare.
Around 66 million years ago, dinosaurs disappeared from the Earth, except for the ones that eventually turned into birds. Suddenly, the Earth went from the age of dinosaurs to the age of mammals. Scientists have special names for these time periods: the Cretaceous and Paleogene, and the event itself is called the KPG, or KT extinction. Picture this dramatic moment in Earth's history. It happened in the blink of an eye. A colossal asteroid as big as Mount Everest and traveling at lightning speed slammed into Earth. It crashed down in what we now call southern Mexico, at a place known as the Chicxulub crater. The impact was gigantic. Everything close to it was instantly vaporized, creating an enormous burst of energy, one of the most powerful in billions of years. Nothing could survive near the crash site. As the fiery aftermath cooled, the Earth's surface went haywire. The ground twisted and trembled, causing unbelievable earthquakes. The continent started to literally bounce. Then, the ocean floor got all stirred up, provoking the gigantic tsunami. Massive waves surged inland around the Gulf of Mexico. The debris that got blasted into the sky started falling back to Earth like a rainstorm. Even if you weren't close to the huge pieces falling in Mexico, you'd still get hit by smaller, super hot bits flying through the air. This heated up the atmosphere so much that forests all over the world burst into flames. The dinosaurs that lived far away from the impact area first felt a little rumble. Suddenly, the sky turned dark and gloomy, as if it was nighttime during the day. The temperatures dropped drastically, and this night during the day lasted for several weeks. And then, a blanket of ash started slowly covering the entire planet. Nasty things like carbon dioxide and bits of the seafloor started floating around in the air. This messed with the temperatures once again, making it swing wildly. The Earth was hot and cold at the same time. Nature was suffering. Forest fires, no sunlight, dangerous gases in the atmosphere. All this caused big problems for plant-eating dinosaurs. They started to vanish, and the meat-eaters were having a feast. But not for long. Soon enough, the whole food chain fell apart. This is when somewhere between 50 and 80% of dinosaurs said their final goodbyes. What's even sadder is that this number only counts the different types of dinosaurs. If we look at the number of individual dinosaur lives lost, it's even higher. Here's an interesting fact. If the asteroid had hit just 30 seconds earlier or later, landing in the Atlantic or Pacific rather than just off the coast of Mexico, we might have had some non-avian dinosaurs still around today. But the way it happened, the asteroid struck with a force equal to 10 billion Hiroshimas. But the only ones who made it were our mammalian ancestors. They were little shrew-like creatures who had super fast energy systems, adaptable diets, or clever hiding spots. These early mammals survived because they were tiny and didn't need much food. We're incredibly lucky that they survived this chaos. They probably didn't even understand what was happening. They just noticed the horrible smell, huge bodies everywhere, acid rain, and volcanoes erupting. So now that we know how terrible this event actually was, let's talk about a big question. Could we, modern humans, survive something like this? Well, it depends. Research from a different asteroid impact about 790,000 years ago suggests we could, but it wouldn't be easy. In that other event, a massive asteroid hit Earth once again. Just like with the Chicxulub asteroid, it sent debris into the atmosphere that covered a tenth of the planet's surface. Scientists found the pieces of that asteroid's impact, glassy rocks called tektites. They analyzed these rocks and discovered a rare mineral called rhyodite. It requires extremely high pressure and temperatures to form. After studying it, scientists assumed that the impact happened in Southeast Asia, probably near Thailand. Strangely, they still haven't found the exact crater. But the main thing is, the asteroid collision did happen, and our ancestors were around during this. It surely got their attention, even though they might not have fully grasped what was happening. The debris from this event would have caused significant climate changes. It's tough to understand how it affected our humans' evolution. All that we know is that we survived it. Currently, there are about 1,200 asteroids on a list of potential asteroid threats, but luckily we're not in immediate danger. These asteroids are smaller than 0.6 miles in diameter. The chance of a massive asteroid like the one that hit Chicxulub between 3 to 9 miles wide striking Earth is incredibly low. Major events like this happen about once every 100 to 200 million years. On top of that, most asteroids are located between Mars and Jupiter and don't pose a threat to Earth. However, there are thousands of smaller asteroids that could potentially hit us. Most of these are small and burn up in the atmosphere, causing no harm. Some larger ones could damage buildings or cities, but wouldn't threaten all life on our blue planet. But what if a comet or a serious asteroid were to collide with Earth today? In that case, first of all, it could alter Earth's orbit. The initial energy released during an impact would cause a scorching blast wave of 570 degrees Fahrenheit. The fire would ignite vast areas of the Earth's surface. Then, it would cause a long-term impact on winter. The smoke from the megafires, along with dust and water vapor, would form a thick layer of clouds in the upper atmosphere. Just like with the dinosaur event, it would reduce sunlight and cause temperatures to drop for decades. Most plant life would die off within weeks. Large trees might survive for decades due to stored sugars and a slow metabolism. Beyond that, not much life would remain, except for microbes and smaller creatures. There are 3 possible strategies for humans to deal with all this mess. The best strategy is to prevent the impact in the first place. Scientists are already searching for asteroids that might cross Earth's path and discussing how to defend against them. One option is to use our biggest weapons to break up the asteroid into smaller pieces. These tiny pieces could miss Earth or burn up in our atmosphere. That would work for asteroids around 0.6 miles wide. However, this won't work for massive Chicxulub-sized asteroids. The amount of energy we'd need to destroy them exceeds our entire current arsenal. But if we notice the asteroid early enough, maybe a series of blasts could change its course and save the day. And, according to the researchers, asteroids larger than 25 miles in size would be nearly impossible to stop with our current technology. Luckily, the chances of something like this hitting Earth are very tiny. But okay, what if we can't prevent the impact? Here comes the second strategy. We'd have to go deep underground and create large bunkers. We know that many burrowing or deep-sea species survived the mass extinction 66 million years ago, so these underground habitants could protect us from the direct impact effects like blasts and fires, as well as an impact winter. We'd have to harness the Earth's natural heat and live inside protective domes. They could be built in stable continental cores or deep beneath the oceans. We'd have some essential supplies like food, medicine, fuel, and water. Maybe even have some gene banks to preserve species. And the last strategy would be to copy the movie Don't Look Up and to ignore the problem until it's too late. We know that it would take collaboration among governments and institutions from many countries to design, build, and launch a series of devices into space in order to prevent the impact. If humanity will be able to pull that cooperation off, that would be a miracle. In any case, NASA takes the threat of asteroids pretty seriously. It has a well-thought-out plan involving early detection, assessment, deflection strategies, collaboration, public communication, and backup plans to protect Earth from these cosmic dangers. So we can only hope that if something like that happens, logic would prevail.